Hello everyone. Today we're going to talk about part 4 of selecting the right tools for your application. And we want to talk about backlash testing, the fast path to production. A couple of housekeeping items. So on the right, you'll see a sidebar. If you want to ask any questions, feel free to put them in there. And we will have a short question and answer period at the end to hopefully get to all your questions. I'm Andy Joseph. I'm the Vice President of Engineering, and I've been with Promess for 29 years. And I spent a large part of that working on the software that goes into our systems.
Hi, and I'm John Lytle, joined here with Andy today. I am the Application Engineering Director for Promess. I worked for Promess for about 20 years now, and I work directly with a lot of the applications that we'll be discussing today.
And what you see here is a picture of our Promess Process Development Center. This is located at our headquarters in Brighton, Michigan. And Promess manufactures press and torque systems for the assembly test market. And we more or less specialize in doing motion sensing in conjunction with force and torque, and to deliver solutions to help our customers assemble higher quality parts. So today, John and I are going to talk about backlash testing and in conjunction with Promess application kits. So let's get started. So first, we're going to talk about what does backlash testing mean for production. And also, there's two basic types of testing, either static or dynamic, and we're going to talk about those. And also the common challenges that we see with backlash testing. And the solution that we offer is called a Promess application kit, and we're going to go into some detail about that. And again, feel free to ask any questions as we go. So what is backlash testing and what does it mean for production? So a lot of times we see gear and shaft assemblies where they need to be able to verify backlash. And a lot of times it's involving doing shim adjustments or doing shim verification in process. And these could be linear or radial types of gears. And some of the things that we want to accomplish in doing this is to be able to detect things such as misassembled gear units, misaligned components, also supplier part variances, and even verifying the tooth integrity of gears. And of course, being able to have the traceability later down the road for warranty claims and recalls.
So here's an example of some of the products that require backlash testing. And I've actually directly worked on a lot of these different products through my career here at Promess. So one picture there is a front wheel drive transmission. Well, inside the transmission, there's a differential. The differential has a gear train in it. So customers and users for us typically need to test that gear train assembly for backlash. Steering gears also have a gear train in the spool shaft portion of it where that couples to the steering column, which ultimately couples to the steering wheel. So there's backlash testing involved in that as well to make sure you get proper feel and for safety reasons also. But there's many other types of applications also, including just gearboxes used in your day-to-day power tools that you utilize at home. Drill, for example, may have a gearbox in it. Those require testing as well as ultra-sensitive gearboxes. For example, gearboxes that are used in windmills need to be very, very efficient, low friction, high gear ratios in some instances because they're used to generate power and things like that. So here's some of the examples. We have lots of experience here at Promess with that.
Now, what is static backlash testing? So what you see here is a torque probe coupled to a differential gear. And I don't know if you can see the mouse pointer. But anyway, so what's happening is that we're picking, let's say, 8 points through the entire gear mesh combinations. And for each point, the torque unit will actually apply a torque in one direction. Well, I should back up. We're actually, on the output shaft, we're actually breaking that and making that rigid. And at each point, along these 8 points, we're actually moving the torque unit forward to a known torque and then backward to a known torque. And we're measuring that position angle between forward and backward. And we're doing that for all 8 points around the gear combinations. And with this information, we are analyzing that and determining what the backlash is and whether it falls within certain parameters. And there's different ways that we can do that. The simplest way is just to take some statistical values of these measurements and put some limits around it. We can also do a parallelogram, which has been popularized by the Edmunds systems that have been out there for a while. And essentially what you're doing is you're plotting a point within the parallelogram, and if it falls outside of that, then that's not considered a good part. And then we can also do more of a spreadsheet analysis where you can actually compare each point against certain upper and lower limits. And there are, of course, other options as well.
So here we have dynamic backlash testing. So really what I've experienced in my 20 years here at Promess is the two different types. Like Andy mentioned, the static backlash testing where you're just finding a point in the gear train and measuring that, or dynamic backlash testing. So dynamic backlash testing offers a little more than just the static. And the real advantage of dynamic is that it allows you to measure the entire gear mesh through the entire gear train. So all the gear tooth combinations get measured. So what it really is the gear assembly is rotated to incorporate all gear tooth combinations. The output is generally holding a resistive load, which forces the gear to the one side that you're measuring, while the input is being rotated and measuring torque and angle. So all position and torque values are then captured, stored, and plotted. The same is done in the other direction. So once it's complete, the clockwise plot is compared to the counterclockwise plot. Each position and torque value can then be analyzed to the corresponding plot in the other direction to determine whether the assembly is functioning as intended. And here's kind of a representative of that. And one additional point that I didn't really note here is one of the things we've learned over the years is we've created a differential graph based off this. So the first graph represents the counterclockwise graph and then the clockwise graph. And then we calculate a, so to speak, differential graph out of that. And then we can put upper and lower limits around that. Additionally, we can pull points off that graph anywhere we want to give you static measurements if you want, or go into more elaborate calculations for calculating averages, mins and max, and things like that.
So some of the key benefits of backlash testing, especially as you think about your customer's perspective, is if you're making vehicles, certainly it's all about better fuel economy. And generally, with any mechanical device, you would definitely like to have less noise, less vibration, less mechanical wear or heat dissipation. And if you're making anything with e-mobility or e-vehicles, it's of course all about travel range.
Yeah, so just to point on that, better fuel economy and increased travel range, it is critical. We're seeing a lot more applications right now based off some creative ways of changing gear trains and things like that to create this efficiency. And customers are creating, using the testing results that we give them, up to 5 to 10% greater efficiency in their gear assembly, which results in directly into better fuel economy in gasoline and diesel type engines, but way more extended range in battery operation also. So big gains are being made there.
So some of the common challenges with backlash testing, I would say at the top of the list is definitely position accuracy and torque accuracy. Quite often we find that you have to use a high resolution encoder in the system in order to be able to really detect those angles and to quantify them. And torque is important too, because you want to make sure that you're applying a consistent torque in both the forward and the backward directions. There's also torsional stiffness and machine flex, and John's going to talk about that.
Yeah, so that's really important as well. They're all important, actually, Andy. But torsional stiffness, machine flex, alignment, all those parts, and all that portion of the machine or the assembly really needs to be taken into consideration. The machine needs to be built like a gauge. And the reason for that is any of those misalignments, machine flex, stiffness, wind up, and things like that, all will be measured. And that'll directly influence the results you get from your measurement on the part. So it's important to take those into consideration. And that's where Promess can help with that as well in our application kits and our experience here.
And another big challenge too is just integrating technology. You know, when you think about it, for a backlash testing application, you've got to have the right sensors, you've got to have the right motor, you have to have the right control environment. And oftentimes in the past, you know, the monitoring system was more or less an add-on. It was more or less an afterthought. And of course, John talked about mechanical coupling and fixturing. And also you need some kind of a braking or resistive mechanism on the output shaft to be able to pull it off. And when you think about it, that's a lot of technology, and each one has its own complexities. And then on top of that, you got to make it all just work together.
In fact, Andy, that brings up a little bit about the history of how we got involved in backlash testing. Andy just talked about the integrated technologies. Before there was integrated solutions like what we offer, it was always a science project approach, meaning that they would buy a sensor from this manufacturer, controller from this manufacturer. They would use some type of coding software to put all this together. And that was really the science project approach. And then it became very, very custom for that particular application. And Promess got involved with kind of our press technology that we've always had, where we kind of sold a complete system for that. It just kind of evolved as we had customers ask us about torque applications. We put a torque unit on the end of our press controller, and then went from there with it. So we started off with our first generation torque unit, and now we're on our fourth generation torque unit, and have taken all that information and expertise that we've learned and turned it into an application kit.
Well, what are application kits? We came up with this term recently, and we have a short 2-minute video that Promess Marketing put together, and I think it explains it quite nicely. So let's go ahead and play it here.
Promess Gear Backlash Kit comes with everything you need to measure and verify backlash in gear assemblies. Included in this kit is a Promess Torque Pro, Promess controls, Promess software, and our 24/7 365 customer support. Our state-of-the-art, non-overloading Promess Torque Pro is capable of measuring gear backlash in both clockwise and counterclockwise fashion. Our versatile transducer system can fit base or flange mount configurations, and is mountable in any orientation to best fit your needs. The Ultra Pro Safety Drive Enclosure is a compact enclosure with drive and safety circuitry built into a singular unit. This pre-tested EtherCAT-based system allows for immediate and lightning-fast data transfer as soon as it's installed. This EtherCAT system transfers data from the Safety Drive Enclosure to the Ultra Pro Digital Signal Conditioner, which provides precise auto-calibration and data acquisition for any gear backlash application. Both the Digital Signal Conditioner and Safety Drive Enclosure are connected to the Ultra Pro Controller. The Ultra Pro Controller is the brains of the system and runs Promess application software specially made for gear backlash testing. The entire application kit comes together into our easy-to-use HMI Backlash software platform. Our versatile software will handle any gear backlash testing application with capabilities to alter torque, rate of change, limits, and many other parameters. And of course, every single Promess product comes with 24/7 service 365 days of the year. One of our Ultra Pro experts is always available to assist with any needs the customer may have regarding our products. The Promess Gear Backlash application kit with our custom plug-and-play system layout is the solution for all your backlash testing needs.
Okay, John, do you want to talk about how a customer would specify an application kit?
Sure, no problem. So here in this slide, you can see that we have A, B, C, D, and E. Basically, the first thing Promess would need to know is some requirements on your application, and that's going to basically dictate what torque unit we're going to use, or what size, or what capacity and RPM that it needs. So that'd be the first thing. Second would be B, which is our safety device enclosure. And we're going to need some specifics on that. Promess offers this safety device enclosure, which gives you your e-stops and things like that. C will be any optional sensing that you need. And just to back up real quick, we're here, we have 14 application engineers here to assist you in any of this. Based off our experience and our knowledge, we can recommend things that you may or may not know, as long as you're willing to share some information about your application. So C is going to be any optional sensing that you may need. D is going to be the controller package, and this is going to consist of any signal conditioners that you may need, how many axes of motion you may need. In some cases, we're using 2 to 3 axes of motion to couple to the input, the output, and any other areas that need to be that need monitor or that need motion. Additionally, we also offer which is part of the package, is a specialized HMI. So this is basically going to be where we talked about earlier, where you're going to see your plots, your graphs, all your information like that. E is going to be any cabling required. So basically some cable requirements we may ask, lengths, things like that, depending on how it's being integrated into the machine structure. And then finally, the entire system is going to come already programmed and tested. So what does that really mean? That means the program to do your actual application is already part of the package and already done. Obviously, there may need to be some tweaks and things like that, but for the most part, programming is taken out of the equation. And of course, like all of our systems here at Promess, they're fully tested and calibrated before they leave our dock.
So going back to the challenges that we talked about earlier, we think that with the Promess application kit that's geared towards backlash testing, we think we've solved a lot of these challenges. And as far as accuracy goes, we're on our 4th generation of the Torque Pro, and that has built-in position and torque sensing that has been refined over the generations with all of our experience in backlash testing. And we also have the ability to add on even higher resolution sensors to be able to pull off the application. John, do you want to talk about torsional stiffness?
Yeah, I kind of alluded to this through the whole presentation already, but I stressed how important that part of the equation is. The machine needs to be built like a gauge. Well, Promess has experts on staff, and we are here to partner with you in that solution. So that doesn't mean we just leave you out to figure that type of stuff out by yourself. So we have, like I mentioned before, we have a full application group here that is available to help partner on your particular application. Collaborate together to make sure the machine is built to the customer's specifications as well as your own, and that it's successful through the entire life of the project.
And on the technology side, by having a single technology vendor, it makes the decisions a lot easier, and everything just works together. And this also comes with our standard application service and of course our 24/7 365 support. And what I also like to mention is the specialized HMI makes it so much easier for the operators to use it and for the folks who are dialing in the parameters to work with it. So what does it mean to be the fast path to production? Well, by having a single purchase order, you're going to lower your ordering complexity drastically. And having a standardized solution, you know, we always talk about in manufacturing that everything's about repeatability. Well, why not extend this idea to improving or expanding your own assembly processes? And having lower technical risk means why reinvent the solution every time? And having spare parts available will definitely mean you'll have less downtime.
To kind of sum all that up, really, it's this simple: a standardized Promess product to create a specialized application solution. Really, that's what we're after here.
Absolutely. That is the end of our presentation content. Let's go ahead and field some questions.
So give us a moment here while we get the questions up here. All right. So the first question is, can your kit calculate what size shims I need to put in? That's a good question. So in a lot of backlash applications, really you're testing the backlash to determine whether that fit is correct in the gear mesh already or whether it needs to be adjusted. And typically in some assemblies, shims can be entered in to be able to do that. So yes, we've done that in the past using our other systems, like our press system, and using positional feedback into our controller. We can calculate shim height and what shim needs to be used so that it can be put into the assembly process and retested. So hopefully that answers your question. Yes, it can be done. And that's also where, in these types of applications, is really where you need to contact Promess and partner with us, and we can help come up with these techniques and methods to be able to do that. Another question: do you build custom machines for this testing? Andy, you want to answer that?
Yeah. So by custom machine, typically when we think of that, we're thinking of something that a machine builder might get involved with, and we have generally steered away from that because these machines can get pretty complex. Now we do offer what we call workstations, and these are simpler machines that we can do a limited amount of torque testing directly on. But again, you really have to reach out to us and talk to an application engineer, and we can steer you in the right direction.
Correct. How accurate is your torque readings? So on our standard torque products, our accuracies are better than 1% of its full range. So basically, on a 20 Newton meter unit, you're going to be accurate to better than 1% of its torque reading. Can you please name all the software used? In our Promess application kits and really all of our systems, the software used is our own proprietary software.
Yeah, and that's something near and dear to my heart because I've developed 4 generations of this kind of software for Promess, and it is our own software, and we do use standard technologies in building it, but what we offer is something that is dedicated to these types of applications, and it's not like you have to go out and try and integrate it with some maybe PLC type software or some kind of data analysis software. It is a complete package, and it's ready to go.
Yeah, so it includes, just to elaborate a little bit on that, it includes full motion, completely programmable, and the monitoring aspect of all this we've been talking about. Next question: can you retrofit your system into a machine to replace an existing testing system? The short answer is yes. It's not always easy to do that with existing equipment, but we have done that in the past. Generally, there's some mechanical considerations that have to happen or will be understood. But for the most part, yes, we can do that. Our systems are also designed to be able to be, like for instance, just the controls can be mounted in an existing electrical enclosure. Our torque units have pretty standard mounting on them. They have a foot mount or a face mount, so they can be oriented in any direction. based off that. So a lot of times we can be retrofitted into an older system. Here's one for you, Andy. Is the HMI built with the PLC?
Great question. So the HMI is actually built with some standard software technologies. It's not derived from any particular PLC product, and it really is geared towards talking with the controller that we offer in our system, which we happen that controller technology we call Ultra Pro. So I guess the short answer is no.
Yeah, I'll elaborate a little bit more on that. We do interface with PLCs, so our controller has field bus options available on it for like Profinet, Ethernet IP, Modbus TCP, and things like that. So if there's other machine functions that you still need to have the PLC or you still want the PLC to control, we interface that way. But like Andy mentioned, the software is our own software. In fact, we have, you know, I boast about our application group and all the experience we have, but we also have a very well-staffed software group that develops a lot of the software. And I think we're up to 15 people that do that right here in Brighton, Michigan.
And one thing I'd like to add too is that through the specialized HMI, when you go to integrate it in a larger system, we found that our customers have actually had to rely less on the PLC to do some of the HMI functions. And we've had a couple of applications recently where they've been able to eliminate their HMI altogether on the PLC and just rely strictly on Promess's HMI.
Can one system measure static and dynamic?
Yes, that is possible. Typically, our customers will choose one way or the other, but there's no theoretical reason why you can't do that.
In fact, to do that, typically you're going to use a 2-axis Ultra Pro controller, so meaning you're going to have 2 torque units, for an example, one on the input, one on the output, and through our controller, you can have one hold position and not move at all to do it statically, and then you could enable that one then to just put a resistive load to do it dynamically. So typically it'll require a 2-axis system to do something like that. How they are clamping the input and output shafts. That's a good question, and that's one that comes up quite often when we're in these applications, and there's multiple ways to do that. I have seen electric and air collets used to couple around the inside of if it's a shaft that needs to be, where you need to engage inside of it. I've seen spline shafts mounted to the end with different types of couplings to the output shaft of our units to do that. A lot of times the spline shafts introduce some error, but one thing we can do in our system that helps reduce the amount of error is we can calculate the amount of lash in the tooling and then compensate for that, things like that. So there's air collets used all different ways. I've seen jaws used as well, a 3-point jaw type end effector on the end of our units and things like that. So.
But I imagine you got to be careful too, John, about damaging the shaft. I think that's a critical thing.
Yeah, there's always a balance between that, for sure.
Yep.
So what is used for the resistance for dynamic backlash testing? So what I've done in the past is, like I said, it's a 2-axis system, so we're using another one of our torque units for the resistive portion of that to force the gear sets to one side as you're rotating it. And we have different modes we can put our torque units into. One is a torque mode that allows it to just put a real-time load on it and maintain that load. We also have canned routines that can be used also. We have canned routines in our software that can also help do that. So basically we have a closed loop torque command, and these are commands, they're all easy menu driven commands that you can put values in to basically get the torque unit to behave however you want it to behave, whether you want to hold the load while the other one's rotating. And that goes into a lot of other applications we get involved with, which is like efficiency testing and things like that. So completely programmable is really the point of the whole thing, and we just would use another torque unit to be able to do that.
Okay, that concludes our questions for this presentation. But again, if you have if you want some advice or if you want to talk to an application engineer, we have the information at the end of this presentation. So hold on, I gotta switch screens.
We're good?
All right, I think we're all set.
Thanks.
Thanks everyone, and enjoy your day.